Welcome to this video on the topic of linear relationships. In this video, I'm going to show you how you can solve simultaneous equations using the elimination method. If we turn our attention to example 1 over here, we have a system of equations. We have 2y equals minus 3x plus 7, followed by minus 2x plus 5y equals negative 11. Now, using the elimination method, we're going to be able to find definitive values for both x and y. Now, to apply the elimination method, it takes about 5 steps. The first step being we need to label each equation. For the first one, I'm going to use the original name of equation 1, followed by equation 2. Perfect. Now, for the second step, what we need to do is we need to arrange both of our equations into general form. Starting with equation 1, I need to make sure that I have ax plus by equals a constant. So what I need to do is this variable term here needs to move over to the left. This will yield 3x plus 2y equals 7, and of course this is equation 1. Alright, now dealing with equation 2, I have minus 2x plus 5y equals negative 11. For general form, I can't have negatives for an x coefficient, so what I need to do is I need to either divide both sides of the equation by negative 1 or simply multiply it by negative 1. This will reverse the polarity of the coefficients. So my negatives become positive and my positives become negative. So thus I end up with the equation 2x minus 5y equals 11. So this is step 2. For step 3, what we want to do is we want to make the coefficients in front of our x equal to one another or similar. So I've got a 3 and a 2. Now for step 3, what I want to do is I want to make the value of the coefficients in front of x equal to one another. Writing this out, I'm going to get as what was seen above, but looking at these, I've got a 3 and a 2. To force these to be equal to one another, what I can do is I can multiply equation 1 by 2, and I can multiply equation 1 by 3. So sort of multiplying this entire equation here by this coefficient and this equation here by that coefficient. This will have the effect as shown. So what you can see is that I've managed to make the coefficients of equations 1 and equations 2 the same at the expense of scaling all the other terms in the equation up, which is what we sort of want at this stage. Now for the next step, what we're going to do is we're going to subtract equation 2 from equation 1. It's at this step here where we employ the concept of elimination. Performing this, I simply get I open some brackets and I get the coefficients and I subtract them from one another. So it's 6 take away positive 6 plus, in brackets, positive 4 take away negative 15, that's y, followed by 14 take away positive 33. Cleaning up the equation, the 6 take 6 is 0 and it's an x, plus 4 take away negative 15, that becomes 4 plus y, and then 14 take away 33 is going to be negative 19. Cleaning this up again, the 0x cancels out because just anything multiplied by 0 is 0, so we get 19y minus 19, and then solving for y, I divide both sides by 19, which in turn yields a definitive value such that I find that y is equal to negative 1. So this is the first value we discover in our system of equations up here. Now to solve for x, we simply employ the substitution method. So if we know y, we simply find x by substituting in y into one of the equation. So sub in y to solve for x. When y equals negative 1, simply solve. I I therefore find that my value for x is equal to 3. So what I find is that the values for x and y are 3 and negative 1 respectively. So in summary, to solve using the elimination method, what we first do is we arrange both our equations 1 and 2 into general form, after which we make the coefficients similar. So we pick x in this case and make them similar, and then we simply subtract equation 2 away from equation 1. This leaves us with a singular equation with a single unknown, which we then find the value of y with, after which we use y to then solve for x. So this is the elimination method. One point of interest is it doesn't have to be the x term over here, you can also do this to the y term to get the same effect. Now, going down one more example. For example 2, what I'm going to do is I'm going to show you how to do it with the least amount of working out possible. Alright, now starting off, I'm going to label both of my equations, equations 1 and equation 2. It's non-negotiable, I always label them. Next step is I want to arrange them into general form. So, picking my equation 1, I'm now in general form, and then equation 2 is in fact already into general form. Alright, next step is what I want to do is I want to make the x coefficients similar. Now notice in this instance we have 4 and 2. Now depending on how good you are with your times tables, you might have noticed that the lowest common multiple between 4 and 2 is indeed 2. So what you can do to simplify this is you can multiply the top one by 1 and the bottom one by 2. This will have the effect of 4x plus 3y equals 2 and 4x minus 12y equals 32. Now in the next step what I'm going to do is I'm going to subtract equation 2 away from equation 1. Performing this, 2 take away 32, 4, then 3 take negative 12, a little bit squished. This yields a result of 0x plus 15y is equal to negative 30. This simplifies down to 15y is equal to negative 30. Then solving for y, I divide both sides by 15. This in turn yields a value of y of negative 2. Now using this value of negative 2, I'm going to say using 2, in fact I don't really need to write that. Rather what I can do is I can just grab one of my equations. In this case I'll grab the modified equation 1 so I don't have to scroll upwards on the screen. I communicate the fact that I am substituting in a value for y. Very important to communicate that. This yields 4x minus 6 equals 2. I simply add 6 to both sides, divide both sides by 4, and thus what I discover is that x is equal to 2. So therefore what we discover is that the definitive values for x and y are x equals 2 and y is equal to. Alright, so this has been a demonstration on how you can solve using the elimination method by eliminating the x terms. Now what we're going to do is we're going to take it up to this line here, and I'm going to show you how you can do it using the y terms instead. So going a few steps back up. Alright, in this instance here what we want to do is we want to make it such that the coefficients in front of y are similar. Now in the equation 1 we have 3 and equation 2 we have negative 6. To make them similar, what I can do is I can multiply this top one by, let's say, 2, and then the bottom one will multiply it by a negative 1. This in turn will have the effect that we get 8x plus 6y is equal to 4. And then on the second equation we'll get negative 2x plus 6y equals negative 16. Now going in for the subtraction, I subtract equation 2 away from equation 1. This will be 8 take negative 2x plus 6 take 6y, followed by 4 take negative 16. On the right hand side, the double negative will become positive 20. I'll get a 0y in here, and then I'll get a 10x. Cleaning this up, I get 10x is equal to 20, and in turn, by dividing both sides by 10, I discover that x is indeed equal to 2. This is in agreement with our solution down here. Alright, now using, let's say, equation 1 again, this modified equation 1 over here, we'll find y. I in turn find that my y is in fact equal to negative 2, which is in agreement with this value that I got down here. So what we're demonstrating here is you can eliminate both x terms and you can eliminate y terms. It's up to you how you want to do it. So in summary, what we had a look at in this video was how we can solve simultaneous equations using the elimination method. This was achieved by first labeling your equations, rearranging both equations into general form, making your x coefficients similar or equal, subtracting your second equation from your first, and then simply substituting your known value into one of the equations to find the unknown, thus yielding the two results.